it's Jen, and I get to talk to you about particles today. More specifically, particle theory. Don't worry, it's not too particular. Later on in my presentation, I'm going to invite you to do an activity at home. To do so, you're going to need to go and get a couple of materials. Matter makes up everything. And matter is made up of small little particles that are in constant movement. And the way that these particles move allow us to know how much energy they have. Let's imagine a scenario for a moment. Now, in science, we try really hard not to personify particles. But I'm going to for this explanation because it kind of helps us better understand particles. It's summertime. It's really warm outside and we're dressed in shorts and a t-shirt. I invite you to go to the beach with me. Now, at the beach, do you think that we're sitting really close one to the other? Probably not. It's way too hot for us to do that. Now, I'm going to change the story a little bit. Imagine for a moment we're still wearing our shorts and t-shirt, but it's the middle of winter. Do we sit really close to one another? Oh, you bet we do. That's a way for us to save energy, right? Well, particles do the same thing. When particles heat up, they gain a lot of energy and move around quite a bit. And the distance between the particles is quite big. But when particles start cooling down, they lose energy and get really close together and don't move as much. When we have a lot of energy, we are actually having a physical change in our matter. So we can go from a liquid to a gas or a solid to a liquid, or if we have a lot less energy with those particles and they're moving a little slower, the physical change is one that goes from a gas to a liquid to a solid. You know what? I have a really cool product that I can use in order to help me better explain this. In my container here, I have some liquid nitrogen. Liquid nitrogen is at around minus 196 degrees Celsius. We're going to use it to show you some particle theory. So I'm going to blow up my balloon to about that size. Now what I'm going to do is I'm going to take out a little bit of the liquid nitrogen and place my balloon into the liquid nitrogen. The balloon, or the air inside of the balloon, the particles of air are getting closer together because they are getting colder. So they are losing energy. But watch what happens when I bring the balloon back to, well, room temperature. The temperature of the great outdoors today. Those air particles actually are gaining energy and are getting further and further apart from one another. And the balloon actually returns to its original shape. Here in my container, I have some liquid nitrogen. Liquid nitrogen is at minus 196 degrees Celsius. Anytime we bring liquid nitrogen above that temperature, it will evaporate, like it's doing right now. The particles of the liquid nitrogen at minus 196 degrees Celsius are getting excited due to the heat and are evaporating. Now watch what happens when I do this. I'm going to place a little bit of the liquid nitrogen inside of my beaker. And then I'm going to take my balloon and place it over the top. Now remember, when we have particles that are getting excited, they're getting further apart. Because we have a liquid to a gas, you're noticing that gas kind of building up inside of the balloon. Now there's two possible outcomes to this experiment. One of them I don't really like. The balloon could pop, or the balloon could kind of floop off the top of the beaker down there. But look at how much, ooh, it's expanding. Oh my goodness. Oh my goodness. When the particles get excited, they get further apart. When they lose that energy or lose that excitement, they get closer together. Oh, I might be lucky enough to not have it pop on this one and just be able to pull it off. You remember how earlier on I asked you to go and get a couple of materials because we were going to do an experiment together? Well, now's the time to take them out. We are going to do two experiments together. The first one, blow up a balloon. Measure the circumference of the balloon using a piece of string. Place the balloon in a freezer. Create a hypothesis. What do you think is going to have happened to the balloon when we go back to get it? Is it going to be bigger? Smaller? Same size? Experiment number 2. We are going to place a balloon over the opening of each bottle. I'm going to place one bottle in a container with hot water and the other bottle in a container with ice water. Let's observe. Now let's switch the bottles. The bottle that was in the hot water is now going to find itself in the cold water. And the bottle that was in the cold water is going to find itself in the hot water. What's happening? Observe. The balloon that was on the top of the hot water bottle is actually deflating. And the opposite is happening with the other bottle. It's because we are actually taking away the energy or adding energy to our particles. Now let's go back and check on our balloon in our freezer. Did it get smaller? Well, let's take our string to measure it. Oh yeah, it did get smaller. That's because the particles had less energy. What would happen if I added hot water? Oh, I'm gonna let you create a hypothesis. I can't give you all the answers. It was a lot of fun adding energy and taking it away to get our particles to move around. Thank you so much for being there, and I hope you had a lot of fun doing science at home. See you next time.